Now, what kind of problem is this? So we're given grams of KO2 and we're given grams of CO2. So what kind of problem would we classify this as?
A limited reactant?
Yeah, this is a limiting reactant problem, right? And we know it's a limiting reactant problem. The way we can tell is because they're giving us grams, whoops. This problem might not be on your notes because I just added it. They're giving us grams of that, and they're giving us grams of this, right? That's how we know it's a limiting reactant problem, right? So in a limiting reactant problem, again, oh, it is in your notes, slide 31. Thank you. When we know this is a limiting reactant problem, and to solve these, we're going to convert them both to grams of O2. And again, if you have a different way you want to solve this and you learned a different way, that's fine. There's so many different ways to solve limiting reactant problems. This one just seems to be people's favorite. So if we start with 12.22 grams of KO2 and 13.5 grams of CO2, right? We're going to convert them both to grams of oxygen. So this first conversion that we're going to do, this is exactly like what's on your exam, right? We need to go to moles. So the question is, how do we go from grams to moles? Periodic table, right? So the molar mass, which again, that's what's going to be on your exam this week, is adding up this molar mass from the periodic table. Now, when we do this, so I'm going to do this in a different color for a very specific reason. This is when we look at our balanced chemical equation. 4 moles of KO2, and we're going to oxygen. 3 moles of O2. Now we want to go to grams. 1 mole of O2 is 32 grams of oxygen. Okay, so the reason I did this in different colors, this is exactly what you're doing for your exam this week. This is exactly what you're doing for your exam this week. This is what is new. That's it. We've only introduced one new thing, and it's this mole-mole ratio. And the only new thing we've done here is we're using that balanced chemical equation to get these numbers. That's the only new thing we've done so far. Again, the first conversion, that's exactly for your exam this week. The last conversion, your exam this week. That's why solving these problems right now is an excellent review for your exam, because if you can do these, it makes your exam, you're like, what? That's so easy compared to what we're doing now. Yep, it is. Okay, next piece. I don't know what I haven't put this in my calculator. This one, it's 44.01 grams of CO2. Again, molar mass. 1 mole of CO2. This time, again, here's the only new piece we have. 2 moles of CO2. Oxygen's 3. Then we go back. That's our only new piece. The rest of it, just what we've done before. 1 mole of O2, 32 grams of O2, and there we go. All right, great practice putting these in our calculator. Yes, I agree. See here, with sig figs, how many sig figs can our answer be? Great practice for our exam. And we see, yeah, 3 sig figs, yes. 4.12 grams of O2. And the reason it's 3, that's 4 sig figs. This one is 3 sig figs. We have to choose the one with the least, right? And the second one, we put in our calculator, you get 14.7 grams of O2. Now, remember, only one of these is real. The other one's not real, it's imaginary. The smallest one is the one that is real. This one is real. This never happened, right? So this means our limiting reactant, remember, must be a reactant. For your limiting reactant, you have two choices. Your choices, either CO2 or KO2. On your next exam, one of the questions asks for your limiting reactant. I think it uses this exact same balancing equation. And like A is CO2, B is O2, C is KO2, and I cannot tell you how many people choose B for the limiting reactant. It's a reactant. O2, that's a product, not an option. Products aren't options for your limiting reactant. Remember that. Products are not options. So this would be our correct answer. Our limiting reactant would be KO2. Okay, so again, just as a reminder, this is exactly what we are doing on your exam for this week. The only piece new is this mole ratio. Otherwise, it's the same thing we've been doing. Okay, so now let's look at using aqueous solutions. So again, this is great review because this is what you're going to be doing on your exam for this week. So we're going to use that aqueous solutions chapter that we just learned, and we're going to combine it with our stoichiometry. So we're going to look at, remember precipitation reactions? Oh, yes. Remember double displacements? That's what you're going to look at. And then we're also going to look at acid-base neutralization, which again, we're just looking at double displacement reactions. And what we're going to do now is we're just going to do stoichiometry with these. So again, these next few questions, great review for your exam. You should have this written on your note card. Molarity. Okay, so we actually have done this problem again, but you know what? This is perfect review for your exam. So try this one, and then we're going to go through this one in just a second. This is very similar. You're going to see these questions all over your exam. So try this one right now, and then we'll go over it in, I'll give you 2 minutes, and we'll go over it.
Professor, the 180.16 grams is basically the molar mass of glucose?
Yes, yeah, I gave you the molar mass this time, so you wouldn't have to add it.
Thank you.
All right, so I'm seeing a bunch of them now. So remember, molarity, moles over liters. This is a grams. We need to convert this to moles. So 36 grams. And this is C6H12O6. I gave you the molar mass this time. 180.16 grams, 1 mole on the top, right? And I'm not sure what that gives us. Anyone have that? 36 divided by 180.16. Oh, I multiplied. I was like, that can't be right. 0.19982. Yeah, we'll just go with everything your calculator says, right? I'm not going to worry about sig figs yet. And then again, it's moles over liters. Over, this is in liters, check, so we can just use 2 liters. And when we do this, we get 0.10 molar. And again, if we look at our sig figs, 2 sig figs, 2 sig figs, we should be good. Okay. And I had 0.1, but I mean 0.10. So this is a great question, right? Really good review for your exam. So let's try another one. Oh, this is a really good one. Again, this molar mass here belongs to CaCl2. So let's try this one. So in this case, we want moles. What do we have? We have 250 milliliters, and we have a 2 molar CaCl2, and we want moles. How many moles of solute? That's CaCl2 is our solute. That's supposed to say moles. Okay, so, well, this is a molarity. See this big M here? Again, that means moles over liters. So there's 2 different ways you can solve this. Whichever way you want to solve this is fine. So you could solve it saying, oh, they're giving us this molarity here, right? And they're giving us the liters. It's in milliliters, but we can convert. So then we could just solve for moles. Sure, you can do that. And remembering molarity times liters equals moles. You can definitely solve for it that way. Or you can do it using unit conversions. And again, using unit conversions, we're doing that so much. So I'm going to just solve it doing that way. So remember, this 2.0 molar, this number right here, this is the same thing as 2.0 moles over 1 liter. That's what this big M means. This big M has these 2 pieces in it. So when we're going to do a unit conversion, remember, if we have a choice to start between 1 unit and 2 units, choose 1 unit. Now, what do I mean by that? Milliliters is only 1 unit. Molarity is 2 units. So don't start with molarity, start with milliliters. And again, there's multiple ways you can do this. I'm just going to solve it this way. So I'm going to start with milliliters because it only has 1 unit. Now I want to go to moles. Well, molarity is mole over liters, which means I need to get rid of milliliters. There's 1,000 milliliters in 1 liter. If you didn't know that there was 1,000 milliliters in 1 liter, put it on your note card or on your paper. Now we have liters. Remember, 2 big M is 2 moles over 1 liter. So I can just rearrange that. 1 liter, 2 moles, liter, liter. And there we go. We have moles, but that's our first question, sorry, is how many moles. And when we do that, we get 250 times 2 divided by 1,000. 0.125 moles of CaCl2. I want you to notice something. I'm going to solve it the other way just so you can see. Here's the molarity, right? There's the molarity. Here's the liters, right? There's the liters. It ends up being the exact same thing. So if we did this solving it molarity times liters, so you would have 2 molar times 0.25 liters equals, you get the same answer, 125 moles. You're going to get the exact same answer. It doesn't matter which way you do it. You end up putting the exact same thing in your calculator. It's just a different way of thinking about it. Whichever one you're more comfortable with is fine with me. Now, if we want to go to grams, you can go to grams from either of these. Okay, so if you went from grams from this one, in 1 mole, there's 110.98 grams, or again, I'm just going to rewrite this so you can see the whole thing. 250 milliliters, 1,000 milliliters, 1 liter, 2 moles CaCl2, 1 liter, in 1 mole is 110.98 grams of CaCl2. Right? So it's again, it's exactly the same. You're going to put the same thing in your calculator each time. It's just a different way of thinking about it. I got it's supposed to be 0.5 moles. 50 times 2 divided by, you're right, it's supposed to be 0.5 moles, not 1.25 moles. 0.5 moles. Thank you. 0.5 moles. There we go. Okay, now that we fixed my calculator error, which again, they totally happen. So we have, again, whichever way you want to do it, works totally fine. 110.98. And so in our calculator, you end up with 55.49 grams of CaCl2. How many sig figs can we have here? Yeah, this one has 2 sig figs. This one has 2 sig figs. So let's fix all of our sig figs, right? So this one, 50 moles. Now that has 2 sig figs. Let's fix this one. It would just be 55. Like a bigger equal. 55 grams of CaCl2. We're going to fix our sig figs, right? Okay, and by the way, this question is literally a question that could be on your exam this week. This is not new. This is just using molarity, just reviewing what we've been doing. So this is a great review for your exam. Okay, so, oh, and there's the answers. 0.5 moles and 56 grams. Oh, look, I got 56 when I did it. 55, 56. Depends on how you did your sig figs on those. Okay, so questions on this one. We're good? All right. Let's do one more of these. So a solution contains 117 grams of potassium hydroxide dissolved in sufficient water to give a total volume of 2 liters. There is the molar mass of KOH. What is the molarity? Okay, this one is all you. So try this one. Again, this is just reviewing exactly this is a great exam question. So try this one. Totally could be on your exam. And then we'll do this one together. I'll give you like 3 or 4 minutes to make sure you try this one. If you're watching this now or watching this later, this could be an exam question. It's not an exam question, but very similar to what will be on your exam. All right, so try this and then we'll go over it together in just a minute. All right, I'm seeing a few come in. All right, again, so many different ways to do this. So I'm just going to do it one way. If you did it a different way, that's totally fine. This one, I'm just going to use molarity. So first of all, the word molarity is what's going to tell us what kind of problem this is, right? And if we look at what we have, a lot of times with when we get to an exam, because there's so many chapters, it's hard to decide how to even start a problem. If you use the little have and want, that should really help narrow down what kind of problem you're looking at. So even if you don't know, if you write what you have, and if you write what you want, and I didn't hit that far enough, it should help you figure it out. Molarity. So if you look at your paper, you'd be like, oh, molarity, that's big M. Big M, that means moles over liters. And then you look over here and you're like, oh, I have grams. I can just convert grams to moles. I can do that. That's easy, right? That's just molar mass. And then I already have liters, so I can just plug those both in, right? So if we have 117 grams of KOH, and they told us, look, molar mass, they gave it to us, yay, 56.11 grams of KOH and 1 mole of KOH. And that is just did it a second ago, 2.09 moles of KOH. Molarity is moles over liter, 2.09 moles over, they already gave us, right? We have our 2 liters. 2 liters. And when we do that, 1.04 molar. Right, yes, and again, when we're doing this, we look, sig figs, 3 sig figs, 3 sig figs, 3 sig figs, right? Okay, so any questions on this one? This, again, totally could be very similar to the questions you're going to see on your exam. Okay, here it is neater, by the way. Well, I actually solved this way the exact way I did it on my computer. Okay. So for this one, again, here would be our answer. Questions? Any questions on this? Good on this one? Yes? All right. So now we're going to use this. So this, again, this is exactly like the questions that are going to be on your exam. Very similar. Like, I guarantee you, there's going to be a question that gives you grams and a question that gives you liters, and it's going to ask you for molarity. It's the only thing that's going to be different. It's going to start with a different grams. It'll be a different molar mass, and it'll probably be a different volume. But you're going to see questions like this on your exam for sure. Now, what we're going to do now is we're going to use this, and then we're going to apply it to something else. So it's perfect to help you for your exam, and this is exactly what your next exam is going to be on, is using these things. So this one, super fun, because this not only combines the stuff you're learning now, but it combines the stuff you learned for your last exam too. So let's look at this. So what mass of silver bromide is produced from the reaction of 37.5 milliliters of a 0.1 molar aluminum bromide with excess silver nitrate? Whew, okay, well, let's look at this for a second. What do we have here? 37.5 milliliters of a 0.1 molar. See how this combines your first exam, your second exam, your third exam, all in one? Number one, you need to know what aluminum bromide is. Remember that? Yeah, next exam's gonna be really fun after this. And what do we want? Silver bromide. Again, you need to be able to write these. Okay, so first of all right, we have aluminum bromide, but we want silver bromide. So we have something, but we want something else. That means somewhere in the problem, we have to do a mole-mole ratio, right? The moles over moles, using the coefficients from a balanced chemical equation. So because we have aluminum bromide, but we want silver bromide, we need to be able to do we need to find the relationship between AlBr 3 and AgBr. We need to figure out what numbers these are. How do I find out what numbers those are? What do we have to do? Any ideas?
Balance.
Yeah, we need a balanced chemical equation here. That's the only way we can get the numbers, right? That's how we get these mole over mole, is you have to have a balanced chemical equation. And again, how do we know we need that? We know we need that because they're giving us something, but asking us for something else. The only way we can convert from something to something else is we have to find the relationship between the two, which means a balanced chemical equation. So here's your exam 2 that everybody loved so much. right? Everybody loved exam 2. So first of all, we need to figure out what are the reactants and what are the products of this reaction. So just loads of fun here. Ideas? Well, if we have AlBr3, that must be one of our products. I mean, one of our reactants. And it says that the aluminum bromide with excess silver nitrate, that must be another reactant. What kind of reaction does this look like? If you had to classify this reaction, what would you classify it as?
Double displacement.
Yeah, it's a double displacement reaction. Yes. So that means we leave Al and we leave Ag, and then we flip the other two. So then we've got and we have to now, next step, check our charges, right? Remember this? This is a +3. That's a -1. So there's 3 there. We're good. This is a +1. This is a -1. We're good. Well, now it's not balanced, right? We put a 3 here, right? And then maybe 3 here. Now it looks pretty balanced. Now we can start our problem, right? So when we're doing this, this is going to combine everything we've learned so far in chemistry, this next piece. So it's great. These are the kind of questions you see on your final sometimes. So now we're starting here. So if we look at, just trying to change this color really quick here. So we look here, we're given 37.5 milliliters and 0.1 molar of that. And we want grams of this. So that means we need to convert this to this, AlBr3 to AgBr, right? So now, these questions, they're almost exactly what we've done before at this point now. And remember, we only have 2 numbers here. We either have 37.5 or we have 0.1 molar. Which one are we going to start with? That's my question for you. Which one of those are we going to start with? Yeah, milliliters, because remember, if you have a choice between 1 unit or 2 units, remember molarity is moles over liters. Start with 1 unit. So if we start with 1 unit, we start with 37.5 milliliters, right? Now our next number, we can't do anything with the milliliters, but we know that molarity is moles over liters. So there's 1,000 milliliters in 1 liter, right? We just did a problem exactly like this. Now we can use this molarity. And I want to remind you, this 0.1 molar, that's the same thing as 0.1 moles over 1 liter. Right, so 1 liter, 0.1 moles, and this is AlBr3. So this is not new, this is not new, this is not new. This is all we did, this is what we did. This is last module that we did. Here is the new piece. Because we're going to convert from AlBr3 to AgBr. 1 mole of AlBr3 to 3 moles of AgBr. That's our new piece. This next piece, again, not new. 1 mole of AgBr goes to, I don't know how many grams. I don't know what the molar mass of AgBr is. I'll look. Oh, I got it, 187. I'm gonna run out of room. 187.77 grams of AgBr. And when we do that, we get 2.11 grams of AgBr. Okay. So to recap what we had to do for this problem. First, we had to write a balanced chemical reaction. That, right, we did that 2 exams ago. And in order to write that balanced chemical reaction, we had to remember, we had to remember our nomenclature, where we had to write all these things down. So we had to do our nomenclature. Then we figured out it was a double displacement reaction. Then we had to balance the reaction, right? So much fun. All of that. So this first piece here, that was exam 1 and 2. That was the material from exam 1 and 2, right? It all comes together. That's the fun thing about chemistry, is that all puts together in little pieces, right? And it never stops. It just keeps building on itself. But don't worry, we're going to practice this a bunch. Then the next thing we did was the stuff we're doing for this exam, right? We had a volume, and then we used our molarity, right? So this is all we did for this exam. Here's the only new piece. That's the only new piece. And again, this is what we're doing for our last exam. So that in this entire problem, we had one new piece, right? It's just that because that one new piece brings all of those other pieces together. And that's why, remember, I was like, you've got to know your nomenclature. You've got to be able to know your nomenclature. Trust me, if you don't know it now, it's going to get you. And I was like, you have to know it. And then I was like, you've got to be able to do these conversions. You need to write your units. You got to write your units. This is why you have to write your units, right? I was so insistent about all those things because this little piece right here makes us be able to use, it allows us to use every single thing we've done in chemistry and put it all in one piece, right? Super fun, right? I think it's fun. Okay, so now, so let's just review what we just did. So we worked on stoichiometry, and now we're just applying that stoichiometry to what we've learned. So again, first thing we had to do was write this balanced chemical equation, which exam 2 stuff, right? Chemical reactions, the module, the chemical reactions module, right? Then we used our knowledge of molarity, which we just learned, right? So we had our volume. In this case, oops, I just went straight to liters. So, oops, milliliters. I just moved my decimal place over on this one, which this should be 0.375. Oops, no, it shouldn't be. It's right. 1, 2, 3. Yeah, 0.375. So I just moved my decimal place over and started with liters. Here's our molarity. Here's that new piece. And then molar mass, right? And so hopefully we all are great with molar mass. All we did was look at the periodic table and added up Ag plus Br. And we got our molar mass there. And all of our units cross off really pretty, and we get 2.11 grams of AgBr. So when we look at this, what did we just figure out how to do? So when we have 37.5 milliliters of a 0.1 molar aluminum bromide solution, and then we add a bunch of silver nitrate, like excess. Excess just means tons, lots. That's all it means. We added a bunch of it. We can make 2.11 grams of AgBr. And so that will be sitting. So remember when we used last couple of chapters ago when we figured out this was a solid using the solubility table. So if I want to know how much solid is sitting at the bottom of the beaker, there's 2.11 grams of solid sitting at the bottom of our beaker. That's how much solid we created. Right? Fun, right? I know, I have a really interesting idea of what fun is. Okay, so now we have another one. This time I gave you the balanced chemical equation, just because, right? Okay, so in this case, lead 2 nitrate, this is our lead 2 nitrate, is mixed with potassium chromate. Here's our potassium chromate. So we added lead nitrate and we added potassium chromate. So if you had these chemicals in your lab kit and you added that and you added that, this is what you would get in your lab kit, right? And then you would use your solubility table and you'd be like, oh, that's solid, that's lead chromate. That's what that solid is. It's lead chromate sitting at the bottom, okay? So the question is, if you had in your little dropper bottle, let's say if you had 0.105 molar of this lead nitrate, right? So that was the concentration written on your bottle. And then you had 100 milliliters of this potassium chromate. And on the bottle, it said the concentration was 0.120 molar of that. We want to know what volume of the lead nitrate is required. So we want to know volume of this. So I'll just say volume. And volume could be in milliliters or it could be liters. It didn't say one or the other, so whichever one. And then we want to know how many grams of this we can make. So if you had a bottle of this potassium chromate and your lab procedure said, and on the bottle it said the concentration is 0.12 molar, and the lab procedure said add 100 milliliters of it to your beaker. And so you add 100 milliliters of this to your beaker. And then the question is, how much of the lead nitrate should you add, right? So how much of that lead nitrate should you add? And then the question is, how much of the stuff is sitting on the bottom? So how much of that lead 2 chromate is sitting on the bottom of your beaker? So all we're doing is we're doing the math of the chemistry. So like in your lab, you're doing the actual mixing it up. We're just doing the math of it, right? So this is fun, a lot, but it's fun. Okay. Whoops. I'm not trying to give you the whole answer. I'm trying to find room so I can write this. Oh yeah, the next one gives me enough space. I was like, I can't write your answer in this space. There, I can do it here. So this is the exact same thing. I just made it smaller so we can write. All right, so when we do this, there's 2 questions we have. So I'm just gonna do the have and the want so we can see this. And I'm gonna stop trying to show you the answer. Let's do this in yellow. Okay, so what do we have? 0.15 molar lead. Lead nitrate. And then we have 100 milliliters of 0.120 molar potassium nitrate. Or sorry, potassium chromate. We want 2 things. We want volume, which I don't know, I'll just say liters, but we could do milliliters. Volume of lead 2 nitrate. And we want mass of lead 2 chromate. So we have 2 things we have to do. Okay, so let's say you have no idea what to do. You're just like, I don't know. We have 2 choices. We have 2 numbers here. We have 0.105 molar or 100 milliliters. We have to start with one of those numbers, or I guess we have 3 numbers, 0.12 molars. If you have a choice, which one should you start with? 1 unit, right? If you have a choice, always start with the one with 1 unit. If there's one thing you can learn from stoichiometry and me, start with 1 unit. You can do it if you start with 2 units. It just makes it a lot harder, but you can, it will work. It's harder. So let's start with 1 unit. So if we start with 100 milliliters, and let's say you're like, I don't know what to do. 100 milliliters. Now, from here, if we have 100 milliliters, and so if we have a milliliters and we have a molarity, which is moles over liters, if we convert this to liters, we can get to a moles, right? So I'm going to convert this to a liters. And by the way, I'm going to do liters like I like to now. I'm just going to go 1, 2, 3 liters. There we are, right? And so now I've got liters. If I have a liters and I use my molarity, I can get to moles. So I'm going to do that, right? I have 0.12 moles of K2CrO4. And again, this, what I'm doing right now, this is the exam that you're taking now. We're just using this and we're crossing off our units. Okay, so now we have moles of K2CrO4. Okay, so again, let's say I don't know what to do now. All right, so we have moles of K2CrO4. Our first question is, we need to get to liters of PbNO3. And again, let's say I have no idea what to do, but what we do know is we have K2CrO4 and we want PbNO3 too. We have something, but we want something else. So if we have something and we want something else, we have to do a mole ratio, right? If we have to do a mole ratio, we can do a mole ratio between PbNO3 and K2CrO4, right? So we can do this mole ratio, which is 1:1, yeah. And where do we look? Right here. They're ones, 1:1. So there's 1 mole of K2CrO4 to 1 mole of where we want to go. We want to go to PbNO3 too. Right, so I just use this right here. All right, so now I have a mole ratio. Okay, so let's again say, I don't know what, okay, I am, at least we're at PbNO3 too. At least I want to go to PbNO3 too. That's the unit I want. The question is, how do I go to liters of PbNO3 too? Well, if we look here, this molarity, this means 0.105 moles of PbNO3 per 1 liter. Look at that. We could just use that here, right? If we put 0.105 moles of PbNO3 over 1 liter, and we cross off our units, moles PbNO3, moles PbNO3, liters. Oh, look, we wanted liters, right? That's our first answer. So we put that in our calculator. I think I already have this. I solved this one earlier. We get 0.114 liters of I'm going to write that so you can see it smaller. 0.114 liters of PbNO3. Okay, so again, let's look at what we've done here. This first piece, that was just, that's this exam now. It's just using your volume, right? So for those of you who like to do this, molarity times liters equals moles. That's what we did. Here's our liters times molarity. We got our moles. This is the new piece. That's the only new thing of this entire problem, by the way. That's the only new thing. All the rest of it we've already done. And it's just back using molarity again, right? So these 3 here are this chapter. The only new piece is that little thing. And again, this new piece just allows us to use everything, right? It just allows us to use everything. Brenda found a little interesting shortcut. Okay, so yes, you can use M1V1 equals M2V2, but I will warn you that only works when the coefficients are 1. It falls apart when they're not 1. So that will work by chance in this problem, only because this was a 1 and this is a 1. So it's kind of like a coincidental, hey, look, it worked, coincidence. If these are not 1s, it will not work, right? So it only works when it's 1s, right? Okay, so now our next piece, and if you're like, what? Don't worry about it. It's a nice little trick that works when it's 1s and only when it's 1s. Okay, so our next part is to go to grams of PbCrO4. And again, this one, it's very, very similar. This is exactly like we just did before. So if we have our grams, we can start with, again, I say start with 100 milliliters. And the reason is because, well, it's only 1 unit, right? So if we start with 100 milliliters, I'm just going to convert this, straight to liters this time. And I'm not going to worry about my sig figs, until the end. And so I'm just going to stick with the K2CrO4. So it's going to look very similar. Moles of except for this time, we're going to go to PbCrO4. So in this time, I'm going to go to, because that was supposed to erase it, I'm going to start here and convert it to here, right? So if I look at that, 1 mole K2CrO4, 1 mole PbCrO4, oops, and we want to go to grams. 1 mole PbCrO4, and that molar mass is huge. It is, 323. Every time I do it, my molar mass erases that I have on my screen. 323.2. 0.2 grams. And we get 3.38 grams of PbCrO4. Okay, so let's look at that again. So in the problem that I just did, this is using molarity, right? This is using molar mass. Our only new piece, again, is that it just allows us to do some crazy things with it, right? So what we found out is if we have a bottle that has 100 milliliters of K2CrO4 and the concentration on the bottle says 0.12, and we put 100 milliliters of this 0.12 molar in our beaker, and then we're going to put, right, this is the same thing as 114 milliliters of PbNO4. So we're going to mix 100 milliliters of the K2CrO4 and then 114 milliliters of the lead-2 nitrate. We're going to put them both in a beaker. When we do that, they mix, and at the bottom is sitting 3.38 grams of lead chromate, right? So it's kind of fun. And again, the only new thing here we're introducing is these mole ratios. It's just that they allow us to do so much, it can kind of be overwhelming the first few times you see it. Again, you're not going to have to be doing mole ratios on this exam. That's your next exam. And by the way, 85% of Chem 219 is exactly what we're doing right now. You just do it with other reactions, and you just literally do this again and again and again and again in different situations. But this kind of the whole basis of general chemistry is what we're doing right now. Okay, so I know it's a lot, but we're going to practice it a bunch. So for your exam, just so everyone remembers, it's just on the measurements, right? The measurements module, the mole, and the aqueous solutions and solubility. It's not on stoichiometry. It's not anything with mole-mole ratios. It's just this is the next piece that we're working on. Go back into the Chem 101 and do the practice problems. Again, usually on Chem 101, you click on the homework tab. Just go over and click on the practice tab. Other thing, go through the lectures that we did on those 3 modules and try the problems again, right? When you're doing the problems and when you're doing Chem 101, whenever you see an equation, make sure you write it down. Or if you see something, you're like, oh my gosh, I don't know how to do that. Put it on your piece of paper. You get to use a piece of paper on your exam. Now, other things for your exam to make sure, there's a periodic table at the top. If you want your own periodic table, that's fine. And you definitely need scratch paper. And remember, when you show your work, you need to show your work so I can follow your work, right? It doesn't have to be neat, but it does need to be organized, right? And again, you can see now why I don't write neatly, but I do try to stay organized. This is why I was so crazy about you writing moles and then the label, right? And then like this and the label, because if you don't do that and you get to this stuff, there's no way you can get the problems right. So you have to be organized. You have to write moles, label, right? Grams, label, mole, label. You got to have all those pieces in there. Otherwise, you're just lost at the next step.